Hello and welcome to Animated Education. Today we are going to talk about vectors. However, I must say that I'm not going to fully explain vectors because vectors is a very broad topic and we will not need everything in physics. So here's what we will need to know. We need to know what is vector. So vector is an geometrical object, at least that's what Wikipedia says, that has an magnitude and a direction. So scalars, so let's say, what is an example of scalars? So for example, mass, okay, mass. So 50 kilograms, okay, 50 kilograms. It doesn't have direction, it only has a magnitude. But vectors, for example, velocity, it has not only magnitude, for example 10 meters per second, but it also has a direction. So here's how we show that we are talking about vectors. So a vector has a beginning, let's say it's A, and it has the ending, so let's call it B. This is vector AB. This is vector AB. We could also say that this is vector A. It's the same thing. I actually prefer to write it as one letter because it's quicker and more convenient. Okay, so now we need to know what an opposite vector is. So an opposite vector would be a vector B, and we write it like that. So it has the same magnitude. Magnitude is written like that. It has the same magnitude, but it has the opposite direction, and minus here shows that it's an opposite direction. So how to add vectors? Well, there are three main rules to add vectors. So the first one is called triangle method. So let's say you have a vector A and you have a vector B. It's very important that B vector starts where A vector ends, okay? So the sum of these two vectors, A vector plus B vector, is a vector C. And this vector C is this. It starts where A vector starts and it ends where B vector ends, okay? So this is triangle rule. Now there is parallelogram rule. I hope I pronounce it right. Okay, so let's say we have a vector A here and a vector B here. This is vector A, this is vector B. So now what we need to do is to complete the parallelogram. So we completed it. We draw two parallel lines and we need to draw a diagonal. So this is vector C. So it's the same thing. And actually, if you think more about it, you could move this vector B here. You could move this vector B here because it's parallel, and you would get a triangle rule. A plus B is equal to C. The last one is called Polygon Law. So we can have a bunch of vectors. One vector, let's call it A, vector B, vector C, vector D, and vector E here. And the sum of these vectors is a vector F. So A vector plus B vector plus C vector plus D plus E gives us a vector phi. Now it's also important to know about vector projections. So let's say we have a coordinate system. This is x-axis and this is y-axis. This is 0, and we have a vector here. Let's call it a vector A. Now, a projection is, so this is a start of a vector, okay? Now, when we need, let's say we want to know the projection of a vector A in x-axis. So, we need to draw a line here. This is x projection of a vector A. Now, this would be a projection in y. So yeah, that's how you draw a vector projections. Now, how can it be useful in physics? So let's see. Let's say we have some cube, okay, some cube with a mass m and some force acting like that. Let's draw a parallel line to this table, let's say, and say that this angle is alpha. Let's say alpha is 30 degrees, okay, and our mass is 2 kilograms, okay, 2 kilograms, and this is a force. Force is a vector, velocity is a vector, force is a vector, acceleration is a vector, and well, many other. Okay, so let's say our friction here is 0. It will be easier for us. So now our force is, let's say, 5 newtons. Our force is 5 newtons. Now we want to calculate an acceleration. So as you probably know, but it doesn't matter actually, a formula for an acceleration would be F divided by m, force divided by mass. So, however, we can't take this F because we want, oh, I forgot to say, we want an acceleration in x-axis, and so we are not interested in that part of a force that is pressuring this cube to the table, okay? We are only interested in the force that is acting, that is helping to accelerate this object. So this force would be a projection in x-axis of a vector F. So let's draw it fully. So this would be a projection in y-axis, Fy, and this is Fx. So if you want acceleration, we need to know this projection of a force. So how could we calculate this projection? Well, we need to remember our trigonometry identities. So let's calculate a cosine of this angle. A cosine of this angle alpha would be force in x-axis divided by all force. So our Fx is equal to force times cosine alpha. That means that our acceleration in x-axis is F times cosine alpha divided by mass of an object. And we can easily calculate it now, and it would be 5 newtons times cosine of 30 degrees divided by 2 kilograms, and we would get 5 divided by 2. Cosine of 30 is a square root of 3 divided by 2, so our force would be 5 squares of 3 divided by 4. And our acceleration, oh, I'm sorry, I forgot. So it would be meters per second square. That would be our answer. So this is how you could use vectors in physics. There are problems that you need to add vectors. There are problems that you need to subtract vectors. Yeah, about subtracting. So there is laws, rules for subtraction to vectors, but I think it's not necessary because it complicates many things, and then you are just a beginner. It's really not helpful to you. Okay, so let's say you need to subtract two vectors. Okay, let's say you need to subtract a vector and minus b vector. So how can you do that? Well, you could simply add these two vectors. So because it is the same thing as adding an opposite vector of b. So if you have a vector a here and a vector b here, okay, so now if you would want to subtract these vectors, you would need to know a rule, and this is what you would get. But you can simply say that our vector a and add vector negative b, and you would get exactly the same thing. Here would be vector c, as I said. Yeah, so I think that's easier to understand in the beginning. You don't need to know many rules. This rule starts to mix in the beginning, then you don't know all of them. So yeah, that's simpler, I think, and it will definitely be enough for you in high school physics classes. Of course, in university you learn all course of vectors. You know how to add, subtract them, how to multiply and do all the other stuff with them. But now it's enough for you for now. So I hope you understood how to use vectors and why they need vectors and what they is, and see you next time.